Our last speaker for the day is Narendran, who will be speaking on engineering excellence. Narendran is a software consultant and head of engineering at a blockchain startup. He has helped both Fortune 500 companies and startups in building products and scaling teams across different industries like finance, e-commerce, mining, blockchain, etc. When he's not working with his clients, you can find him serving brewed coffee at his cafe in the mountains. Well, that is something that you would want to do. Please welcome Narendran to the stage.
Okay. Yeah, it's been like a long day. Even it's a bit tiring for me. I can understand how tiring it is, but buckle up. Let's try to make this worthwhile. And this talk is not about tools, code, or CI/CD. I mean, we'll talk about it, but like not entirely about that. This is about thinking and first principles. And we are going to see what engineering excellence is from three perspectives: product, organization, and the developer itself. So about me, I am a full-time adventurer with Tensoon. That's Tensoon. And I'm a software consultant. I head engineering at Arcana Network. We abstract away blockchain into tools and SDKs so that you can build apps on top of that. Go check it out. And I, as the stereotype goes, I took coffee a bit too seriously. I started serving coffee at mountains in a small town. And rest of my day, I just shitpost on Twitter. That's my Twitter handle. So let's talk about software. But first, coffee, right? So how many of you here loves coffee? Yes, great. And how many of you here drinks instant coffee? All right, need to come out, we need to talk. So how do you make espresso? So there are like basically 4 steps. The first one is you dose the grounded coffee powder into the portafilter after your grind settings, and you distribute the grounded coffee evenly, and you tamp it so that you can remove the air pockets in the grounded coffee. And then you run pressurized water through it so that you can extract the coffee out of it. And the final step, and the most important one, is you sit back, relax, and enjoy your coffee. And these 4 steps are not just steps, they are also variables. We'll get back to this later again. So what is software engineering? Right? Software engineering is writing code that changes with time, people, and scale. I repeat that again: time, people, and scale. What is engineering excellence? It is efficiently delivering products to the customers, and while doing so, you take pride and satisfaction from the work. It is also the non-functional requirements that keeps the system running, right? Like it improves the daily work and productivity of the engineers. And it is sort of a journey, and it's a continuous journey. It's not an end goal, or like there's no destination. So let's talk about engineering excellence, through products lens, right? So basically, products goes through sort of 3 phases. One is pre-product market fit, and right when you find the product market fit, and then post-PMF. So in pre-PMF, basically you will be shipping prototypes, and you have to prove your product to get your early adopters. If you don't have early users, probably you'll go back to the whiteboard and find out what went wrong. And you pivot sometimes, or sometimes you shut down. And so at this point, like writing maintainable code or doing engineering excellence doesn't matter, right? So you'll be building your prototypes, or your product has like an imaginary castle, and you won't know how the users are going to use it, how the market is going to react. And the user might be doing something entirely different, where you spend so much time and money on getting different kinds of prototypes for them. So, and the next phase is you find the product market fit. So now you got your early adopters, and now you have to start building the new features for your early majority, basically next set of users, right? Like you will get the feedback from the early adopters, and you have to start implementing, and you'll probably try to fix the screw ups and the shortcuts you took in the product, as well as the engineering, and all these while catering the existing early users. So what happens post PMF? So basically, you found your product market fit, and you got your yearly majority, and now you have to gain the late stage adopters, right? So you will be focusing more on the business side, and you'll be expanding the business globally, and probably new product verticals might be popping up. And by this time, if there is no engineering excellence, there will be only misery. Either the product will be miserable or the team will be miserable. And we're not going to talk about miserable things today. Secondly, it's out of the scope for this talk. And always there are like few exceptions, right? So a fortunate exception is when your product ends as a cash cow. So basically the code you wrote sits for years and years, and it generates money. And that's what you call the legacy code, right? Only few people have access to that code base, and no one goes near it, and you can't go and touch the code base unless you're in that company for a long time. And an unfortunate exception is fighting for survival. So if the business is trying to survive, if the business needs cash flow and user traction, basically engineering excellence will take a backseat, right? You have to keep the lights on. The common factor here is change, right? So you always try to optimize for change. You try to adapt to change in the product level, the code level, and the team level. And yeah, you can say nothing's gonna change. Let's say like I'm not going to change the requirements. The market is not going to react. But the mindset of nothing's going to change is a very risky bet, because even an idle code after a few years, either dependencies get bloated or you need to upgrade the dependencies. The more time passes by, the more severe it will be. It will go from just libraries to virtual machines to operating systems, right? And then there is unstoppable change inducers, entropy, and passage of time. The system always decays. You can't stop entropy, you can only slow it down. Now let's see why engineering excellence is important from organization's perspective. To look at that, we'll take the startup's narrative, move fast and break things. Like, you won't be able to move fast and break things if you're not able to undo the broken things, right? Like, you don't want to move fast and leave a trail of broken things all over. And if change is the only option for any product, only when the change is undoable, people will be ready to make mistakes. People will be confident to make mistakes. And startups and organizations goes through a lot of breakpoints in different phases of the product and as the team grows, right? So the breakpoint will happen when the team tries to scale the architecture. When being a small team, they'll try to adopt microservices because that's what everyone is doing. And then Conway's law kicks in and comes say hi. And then you struggle to maintain the microservices being a small team. Not just that, the communication bottlenecks between the teams, the integration issues between the teams. And there's this huge chasm created, and some startups go through it, some struggle and bleed a lot. So now we know what engineering excellence is and why it is important. But you can think, right, like you can just do engineering, right when you start the prototype, or like right when you hit your product market fit, you can think that you can stop everything and just focus on the engineering. But real world doesn't work like that. It's messy and chaotic. So 80% of the engineering problems you are facing or you would face in future can be solved by fixing 20% of the issues. And since one of the major common factor is change, we need to learn how to handle change. And in order to embrace change, you have to take continuous decisions daily and continuous trade-offs, right? As the company grows and as the team grows, engineering will be taking continuous trade-offs and decisions every single day. It's as simple as cutting a cake for the birthday party. So if you're a 10-member team, yeah, okay, probably the birthday will fall throughout the year and it'll be distributed throughout the year, so you can cut for every birthday, and all the 10 people can be present in that party. What happens if your team grows to 30? Most likely it might fall in every 2 weeks, and yeah, it's manageable, but do all 30 members should be coming to the party when they have deadlines? Is it going to cost too much for the productivity? And next thing is, what happens if your team size is like more than 300? Most likely the birthdays will fall in every single day, right? Does the party planning committee have budget for buying cakes every day, or like should all 300 be present? I mean, that's not really possible. Or should you batch month by month? I mean, this simple cake cutting analogy tells you that like you have to take continuous decisions as you grow. And when you take decisions, there are two kinds of inputs and outputs. So one is measurable and immeasurable. So in measurable, basically you can quantify the inputs. For example, CPU cycle time of code, and you can calculate it, and you can say that you will incur this much cost in future to scale this code. And the costs there are direct. And if you take immeasurable decisions, the inputs and outputs cannot be done using dashboards or data. So, for example, lack of tests and lack of docs or the API contracts. And here the outcome, here we don't have like measurable outputs, it's just outcomes and impacts. So I can't just go and tell someone that if you don't write tests or don't write docs, you will lose X hours of productivity after 1 year. We can't do that. So here we rely on expertise and leaderships. So one more important thing to handle change is you need to detect the change as soon as possible and undo the change, right? So you need to find the change as soon as possible. Like for that, you need to reduce the feedback loop. It doesn't matter whether you're writing integration tests or you're writing API contracts or you're sitting inside the same room during the integration. Well, like for prototyping, a single conference room would do. It will reduce the feedback loop between the teams. But that won't scale. To scale, you need to start shifting left, right? So basically, you need to bring all the issues and detect them earlier in the developer timeline or the developer workflow. So the longer you wait, the more costly it will be to fix that issue, and the cost of the issue keeps increasing, right? End of the day, if you let the issue go to the users, you can just sit and pray that no one trashes you on social media. And while bringing changes, one thing which is really important to note is having a change of mindset over policy, right? Policy is very easy to set, and you can just say that, document everything. But how can you expect a team to have document-first culture if they don't have the habit of writing? And even the remote team, right? Like you can't say a team is async and remote if they don't know how to communicate efficiently, right? So change brings resistance in people. That's how humans are. Like you are insecure. I mean, we are insecure, everyone. And you will have this resistance. It can be active or it can be passive. So like there are teams which will show active resistance to change, and there are people who will show passive resistance, like unconsciously. But at least active resistance, you know that there is resistance and you can talk to people and you can solve the problem. So that's why you always have to sort of retrospect whenever you bring in change, either through one-on-ones, or you need to see how the people or individual or teams feel about the change, so that when you get a perspective of that, you can convince them that why this change is important. And so how a healthy engineering team looks like. So there are like few things that you need to focus on to build a healthy engineering team. One is knowledge sharing. Form a writing habit, as we said, like documentation culture. Documentation is important, right? Like for that you need to form a writing habit. And one pages and meeting notes are really a good start, and you can just start dumping the thoughts on pages for repository wise, or like blocks of the architecture. And you can't call yourself a remote async company if you don't write meeting notes. I mean, if I'm working remotely and asynchronously, if I miss a meeting and if I miss the whole context of the day, that's not doesn't sound good. And you need to deliberately refer to the written docs to create that documentation culture, right? Like if people are asking questions, you have to ask them to refer the docs instead of you giving the answers or getting on calls. And it will help this all or nothing expertise, where one set of engineers know too much about the product, where they have worked from the prototype level and they are with the company, and there will be new hires where you have hired to scale the product, and they take a lot of time to get onboarded, and eventually these engineers will get pulled and they have to educate them and as well as work on the prototype, which is going to become the foundation of your product, right? And when the team grows a bit, when you have individual functional teams, you can have like internal talks to avoid the information islands. Information islands is something which one of the team or one person will be doing something really good and they don't propagate that culture to other teams. And constantly encourage your team to communicate and be proactive about everything. There is no such thing called over communication, especially these days in remote work setup. And the team should always make some sort of noise, because a silent team is a dangerous team. Okay, silence can mean two things. Either the team has 100% clarity on what they need to do and they don't have any issues at all, but you cannot have 100% clarity, right? So that means silent team is always a dangerous team. There is something wrong going on. And you need to encourage proactive learning instead of just reactive learning, which means like, yeah, Googling and find out is okay, but it should not be the case for everything, right? If you don't have proactive learning, and if you, the thing is like just getting the subscriptions for learning platform doesn't cut. So they have to have like some sort of priority and time to learn. If all you have is subscriptions and all you do is busy work every day, no one is going to spend time to learn things. What happens there is the team will start doing parroting. Basically, parroting is mimicking and copying the patterns. Like, yeah, these guys do this kind of design pattern, so let me do that. Or they will start following different patterns which without knowing the reason why they're following it, right? And so whenever we hire engineers, there is always this untold or unlisted part of the job description, which is the individual productivity. We all assume that every good engineer or every engineer in our team is going to be really productive. They know how to manage their time, they know how to manage their energy and how to prioritize work every day. But yeah, I can assure you that I'm really whack at that. I mean, most of them are. And so no one talks about it inside the organization. Only few does. So you need to be loud about that. Probably get one of your productive member and ask them to brainstorm about it. Have like a casual fire camp session about it. And from your side, you have to like prioritize heavily to reduce the streams of work, right? Like if someone or some team can't fit their work in their mental model, then probably they're going to drop balls and they won't be able to unblock the other teams and things slip through. So everyone in the team must be able to have the mental model, at least for the current cycle of work or the sprint, whatever you call it, right? And you have to create psychological safety for the team, because if if you learn by making mistakes and you're afraid to show your mistakes out there, you won't be able to reduce the feedback loop by getting faster feedback. If you're not able to reduce the feedback loop, then you won't be able to embrace the incoming change. If you're not able to embrace the incoming change, then you won't be able to grow, right? So, and finally, when it comes to productivity, don't measure the lines of code or number of story points or issues closed. There'll be a lot of PMs here who might disagree with that, but that's not a topic for now. Evaluate the impact the team has on the product and in the release cycle. So, one more important thing is let the team believe in expertise and experience, right? If the team is not able to take continuous trade-off, then they need some sort of seniors or engineers to guide them, or a good leadership to guide them. So, or else again, the parroting issue happens. Parroting, again, copying the patterns without knowing the reason why. So, and also you need to incentivize long-term efforts. So, like basically, instead of incentivizing firefighting on nightly basis, you would rather incentivize the team for putting out the measurements to avoid these kind of issues. And a stretched team will always miss out on the engineering excellence, right? Like if you're too busy to close the issues and move on to next thing, documentation, testing, and other practices are always going to take the backseat. You always have this unsaid vibe of you have to like move next. You will do the docs later, you will do the test later, and you will never do it. You will just, for every step you take feature-wise, you'll be like taking 5-6 steps backward in engineering. And whatever you do, there is going to be time and entropy to make sure the process decays. And slip-ups, you need to address these slip-ups then and there. So if there is some people who don't follow these things, and the other members in the team will think that it's okay to do that, and eventually it becomes a norm. So leave no broken windows. And whatever change you introduce, you have to keep it really simple and stupid, right? Like think of the changes as the cogs in the system, and like some might be bigger and some might be smaller. If you rotate one, then it affects the others, and eventually it affects the whole system. So I think I have 3.5 minutes left. Let's see why engineering excellence is important to an engineer or the developer. Let's go through it quickly. It actually helps you grow in your career, right? You either get promoted inside the company or you get more opportunities outside. Basically, communication is part of excelling at your work, right? When you communicate effectively, you'll start propagating good culture, and people will eventually come to pair with you or take advice from you, and there you start influencing without authority. So either you'll get promoted into, you'll become a natural leader. So you will either get promoted into leadership roles inside your company, or like you'll be like getting opportunities outside. And about how to show excellence, I think I'm going to skip it. I think I already planned this because I want to squeeze this talk into 25 minutes. So yeah, you can go check out my previous talks or writings where I talked a bit about individual, excellence and software craftsmanship. And as a developer, always remember that the dev who is going to maintain the code is so buffed up and beat the shit out of you if you don't write good code. So you don't want to be the person who is going to just write a quick POC. You have to learn and level up to write sustainable software. And to conclude, let's come back to coffee. So we saw these 4 steps, right? So these 4 steps are also variables in the coffee. So basically, if you adjust one of these steps, it will affect the taste of the coffee. And a good coffee has balanced acidity, body, and bitterness. So basically, extraction time is also one of the variable. So if you keep increasing the extraction time, if you let the water flow through the coffee for a long time, it's going to get bitter. And the acidity will acidity will decrease, and the body will also decrease. The espresso will become too liquidy. And so let's say if you try to reduce the extraction time, and the acidity will increase, which means the coffee will taste very sour. Similar to that, there are variables in engineering, and every project tries to optimize for quality, speed, and complexity. So when you start the project and when you go from the prototype level, you feel that your speed is increasing, but silently complexity will catch up, and eventually your quality will go down and your cost will go up. And the three things like organization, product, and the teams or the engineers are also variables, and they're also part of the system. So you need to find out which variable you can tune and how the system reacts to that. And you need to build everything like you build castles in sand, but you build it like it is built using rock, right? So I think that's it. Perfectly on time. Thank you.